Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in previous video, we had understand how the k nearest neighbor algorithm works, right? So in this video, we will implement that KNN from scratch using Python and NumPy, and then we will compare our result with sklearn. Okay, so let's get started. So let me first import few libraries. Import NumPy as np from scipy. Import stats, right? Okay, so we'll define first a class, let's say KNN classifier, right? And then one init method would be there which will initialize our required parameter. So we are just using only k here, and let's say by default k would be 5, right? Self.k is equal to k. Okay, so we will use three methods basically here. So one is fit, which will have the code about the training, right? So let's say it will require two parameter, xtrain and ytrain. Okay, let it pass as of now, we'll implement it later. Then second method would be predict, right? It will take only x. Okay, so we will return the y corresponding, which we will predict. And let's define another method which would be Euclidean distance, right? So let's say define Euclidean distance. It will require 2 points and return the Euclidean distance from that. So let's say distance is equal to, we will use NumPy method here. So let's say np dot square root of np dot sum x1 minus x2 start 2, right? So x1 minus x2 square plus y1 minus y2 square all in the square root. This is the formula of Euclidean distance. So we have just implemented that here using NumPy. Let's return a distance. Okay, so now let's implement fit and predict methods. So for fit, we had learned in KNN session that KNN classifier or regression, it's not doing anything in the training but just storing a training data set, right? So let's store training data set. We'll just assign, let's say, store training data set. Okay, let's say self x train is equal to x train, self dot y train is equal to y train, right? Okay, so now let's implement the predict method. So what we have to do in predict method, right? So we will get one query point or multiple query points in a predict method, and we have to find corresponding label. So how we will find the corresponding label? So basically we will take one query point at a time and find a distance of it from each query, each point in the training set, right? So we will get the distance of that point from each training point, and we will select top k value. In our case, k is equal to 5 currently. So we will take top 5 value which are most near or nearest 5 values from our query point, and we will get a label for those point from the training set, and we will use majority class. Okay, so let's implement that. Let's say I have x, so let's convert x into the NumPy array first. Okay, so now let's iterate over each query point in the x. It might be one point or multiple points. So let's say q in x. Okay, so let's say we have to calculate the distance of q from each point of our training set, right? So it would be like, we can write distances is equal to, let's say, self dot Euclidean distance which we had defined, right, of query point and x, let's say. So from where x will become, it will be like for x in self dot x train, right? So for each training point we are calculating a distance, right? So now we have calculated the distances. So let me write comment as well. So calculate distance for each training point from query point, right? So now we have to find top k or nearest k value. So we can use NumPy function np.argsort, which will provide the indexes of nearest value, right? So let's say neighbours is equal to np.argsort and distances. So we just need top k values or nearest k value. So let's say self.k, right? So now here we get the neighbors, but we want labels for each corresponding neighbors. Then we can only calculate the majority vote, right? So let's first write it down comment here as well. Get nearest k neighbors, right? Yeah. So let's get the labels for neighbor, right? So it would be like neighbors label is equal to, I think it's spelling mistake. Okay, let's see. Okay, neighbors of not the neighbors, so we have to find it from xy train, right? So let's say self dot y train of neighbors. So basically what we had done here is we get indexes for the points which are very nearest to our query point, and here we had extracted the labels for each point, right? What is here? Okay. So extract labels for k neighbors, right? So now we have labels. So now just our task is to get majority vote, right? So let's say get majority vote. So it would be basically simple a mode, right? So let's say mode is equal to states dot mode, and we will pass our neighbors label. So this is our result basically. Okay, label, right? So we have multiple query points here, right? So let's define one result list, and we will append our result into that, right? Results dot append mode, and after one process is completed for each point, we will return that. Okay, let's say return results, right? What is the issue? Okay, spelling mistakes. Okay, so this is all about the KNN. So let's now test it out, right? Let me remove extra spaces here. So this is our whole KNN function. Yeah. Okay. So for testing it out, we required dummy dataset, right? So for dummy dataset, I would use a scikit-learn function, which is make classification. So let's import some libraries which would required for us. Let's say from scikit-learn.datasets import make classification, right? And let's say import some metrics also to evaluate model, right? So let's say scikit-learn.metrics import accuracy score, and let's say confusion metrics as well, right? And let import train test split as well, so we can divide our data into train and test set. Let's say from scikit-learn.model selection import train split. Okay, so what is the issue? Okay, so again one spelling mistake. Let's try run. Scikit-learn. Okay. Again, what is the issue? Let me check. Okay, so S is capital. I think now it will work. Yeah. Okay. Let's import everything. Okay. So now let's create a dummy data set, right? So let's say x and y is equal to make classification, right? So it will require n samples. Let's provide n samples is equal to 1000. So we will get 1000 samples. And if we see the arguments, so you can see here the n features are 20 and n classes are 2. So it's okay for us to testing. So we are leaving it as it is, okay, and just provide a random state is equal to, let's say, 42. So you can also get the same output as me, right? Okay. So let's say check the shape of x and y. Yeah. Okay. So we get the 1000 sample with 20 features and 1000 labels corresponding, right? Okay. So let's divide it into train test split. So we can say x train, x test, y train, y test is equal to 10 test split. And let's provide x and y, and we can provide test size is equal to 0.2. So we are splitting data into 80-20 split randomly. So you can see here, like, we have to provide test size and random state, right? Supple is basically true, so we are not providing any argument for supple. Let's provide only random state, so everyone can get same output, right? So let's say random state is equal to 51 here. Let's run this and let's check shape as well. Xtrend dot shape and ytrend dot shape, right? Okay, so here we can see we get 800 into training set and 200 sample would be in test set, right? So let's call our KNN or train our KNN implementation, right? So let's say KNN, I would say customknn is equal to KNN. So I am leaving K as it is for our this implementation, right? Okay, so now customknn dot fit, let's say xtrend and ytrend, right? Yeah, so our model is trained, so basically it is storing xtrend and ytrend. And now let's predict one value, customknn dot predict. Okay, it will be like this. Okay, predict, and let's predict y test of, let's say, top 5 first 5 values, right? So let's say, okay, yeah, so we get the result like 111 for it, right? Okay, so I think we have to change the code little bit. It is written in mode 1 and count 3, so I think we should change that as well. Let's see here. So let's see what the state.mode reads, right? Written. Let's say scipy states mode. Okay, so this is the best practice to go to the documentation and check out the code, right? So if we see here, it will return a mode, numpy array and count, right? So we can do it like this. Let's test first in another cell, right? So I'll show you how we can just test any function if you want, right? So here it will be mode and let's say count, right? And I just want to get mode from, let's say, dummy array 1 1 1 2 2, right? Okay, so here we can see like mode would be 1 and count would be 4, right? So we are getting same. So let's update our code according to here would be mod count, right? So let's rerun everything again. So our KNN would be again retrain. Okay, so now we get the output in the format which we want, right? So let's say what are the I think predicts X test. We had done small mistake. Let's say X test of 5. Now it will work. Okay, so let's see white test here. White test of top 5 which we had provided for the prediction, right? So here we can see the for X test we are predicting this for first 5 value we are predicting 0, 1 and 000. So here also classes are correctly classified, right? Here. So let's see the accuracy as well. So let's say accuracy score. For accuracy score we would require all prediction, right? So let's say custom y pred. Let's say y test pred basically. So it will be like custom KNN that predict X test, right? You can do same for a training set as well. So we can get better idea how the training algorithm, how the training work and testing data set is working, right? Okay, so let's say train. Okay, so let's say print training accuracy on custom arcade scratch KNN, right? We need to print both for training and testing. Let's say it would be like y test. So we are providing original value and predicted value. Same goes for here for training set. Okay, so let's see the accuracy here. Yes, so here we can see on the training set we get 0.87, so it means like 87% accuracy. On a testing set we get 81% accuracy, right? So let's print confusion matrix as well. So let's say confusion matrix for let's print confusion matrix for test set, right? Okay, spelling mistake again. Okay, I think now it would work. Yes. Okay, so here we can see like 86 are correctly classified and for the positive class, and 77 are correctly classified for negative class, same as these are the false prediction, right? Okay, so now let's understand this was our custom implementation, like from scratch we had implemented. So now let's see the scikit-learn library, what are the parameters it contains, and we will understand each parameter, and then we will implement that as well and check how results are coming, right? So let me go to the scikit-learn package. Okay, so here there is a k-neighbor classifier is there. So there are few parameters which we need to understand, right? First, so let's say there is first is neighbor. So basically it is our k. So by default it is 5, which we had also implemented k is equal to 5, right? And this is the weight. So there are two basically values are there for uniform and distance, and you can pass your any functions if a callable function, right? So uniform means we are just taking majority class. We are providing equal weight to each classes, right? And distance means, so if you recall in previous video we had learned like weighted KNN, right? In which we are using inverse of distance and then calculating output, right? So this is basically that weighted KNN scheme. So if you read here, it is saying like weight points by the inverse of their distance. So they are using 1 by distance and then summing up, and then whoever is larger they will provide the output, right? Based on that. If you not recalling that, I would suggest like go back and that understand my previous video about the KNN. Okay. So there are some algorithms like bolt tree, KD and brute. So there are three kind of algorithm which can be used to find optimal neighbors, or I would say like top neighbors, right? Top k values. So there are different implementation which is bolt tree and KD tree and the brute force. So what we had implemented, it's brute force, and there are two other techniques are as well. So KD tree is basically, these are some tree based techniques which some kind of optimize of searching nearest neighbor. Okay. So there is leap size, so it will use when we are using KD tree or bolt tree. So how much points we need at the leaf node and that kind of thing is here. Okay. So this is P float value. It required default it is 2, right? So if you recall, we had understand that Minkowski formula, right? So which is a generic form of a Euclidean and Manhattan distance, right? So if you provide P is equal to 2, then it will work as an Euclidean distance, right? If P is equal to 1, then it will work as a Manhattan distance. And if you any number, if you apply any number to P, it will be like considered as a Minkowski distance, right? Okay, so these are some parameters. So njob, basically it will use your how much CPU you want to use while training. So this is about the njobs, right? So it can run a parallel job on the CPU and utilize all cores of the CPU, right? Okay, so let's implement that this algorithm as well, and we can see how much it is related to our implementation, right? So let me copy this three line of code. So this is the beauty of sklearn. We don't want much lines to code, right? So let me paste it here. Yeah, so this is about the sklearn. So let's put the neighbors is equal to 5 because we are using with the 5, right? So let's say xtrain and ytrain, right? So the model is fitted of the from sklearn, so it is already trained. So let's see how it is predicting, right? So let's say sklearn KNN train prediction. Okay, so let's say dot predict xtrain and ytrain. Let's do the same thing for test set. Test. Okay, so let's run this. Take 2 positional argument, but 3 were given. Okay, yeah, so for prediction we don't provide this y, my bad. Okay, yeah, so let's print the accuracy for that as well. I'm just reusing this code here. Let's say xtrain enter for test, right? Okay, so here you can see we get exactly same result, right? For our solution or custom implementation, it would accuracy is 0.87125. Here we get same accuracy for training 87125, and the accuracy of the testing side also 0.815. Here also 0.815, right? So we can say we had implemented a best version of KNN with the brute force. So there are other implementation as well, like for searching. It will not impact result much, but it will improve searching mechanism in the KNN to find the nearest neighbor, right? So yes, so you can see here we had built very well. So this is all about the KNN implementation. If you have any query or doubt, you can write it down in comment section. I will reply there. Okay. So if you like this video, please like, share and subscribe my channel so we can grow together. Okay. So we'll see you in the next video. Thank you.